Hello class and welcome back to Holber Helps. Today's topic is systems of linear equations. Specifically, we're going to be going over the substitution method in this video. So before we even get started on how to do the substitution method, we need to talk about what is a system of linear equations. A system of linear equations is when you have two or more linear lines and you want to find where they cross. So we would graph them and you could check where they cross, like for example, right there is where they cross, and that would be our answer. Okay, so that's what we're looking for. That's what we're solving for in a system. And since we're solving for where two lines cross, it's important to note that our answers are always going to be written as x comma y. And we need to find the x and the y for this system of linear equations where they cross. Okay. Now, shifting our gears over here, when we are solving a system of linear equations, we actually have three different answers we can get. For the first one, we have the normal, just everyone's favorite, one solution. So we have two linear lines, they cross at one point, and when we get one solution, it'll look something like we'll solve all of it and we'll get to a point where it's like x is equal to 3. So we'll have our variable on one side and a constant on the other, and then we would have to also solve for the y. And we'll go over an example of what this looks like in just a minute, but this is one solution. And this is our first type of answer we can get, 3, 2 for where they cross. Our next option is a little bit less of a favorite, but still quite nice. And that is when we have no solution, where both the lines grow at the same rate, so they're parallel, so they will never cross, ever. Okay? So since they never cross, we never find an answer, and what that will look like towards the end is we'll get something just totally silly. So we'll have no variables at the end, but we'll have something just completely preposterous like 3 is equal to 0, which that's not possible, right? 3 does not equal 0. So since that is untrue, we would say that there is no solution. And then we have one last one, which is where secretly both of the lines are actually the same line and they perfectly lay on top of one another. And this is all solutions or infinite solutions. Both of those would be accurate. What our answers will look like here is we'll get to a certain point where we have the exact same thing on both sides of the equation. Emphasis on the exact same thing when we're solving. We'll get somewhere like here, it'll be the exact same on both sides, and we'll know that this system of linear equations is actually all solutions. Okay, now I'm going to go through an example of how to actually do the substitution method, and we'll go over what each one of these answers might look like in a normal problem. Okay, so let's go ahead and get started on question 1. Okay, so class, as you see here, we have our first problem on how it might be presented to you. Find where the following linear lines intersect. And over here we have our two linear lines. So the substitution method is one of 3 different ways you can solve a system of linear equations. And spoilers, it actually always works, but there are times where it's better than others. And what you want to look for is if you have 2 equations, right? You want to check and see if one of them have a variable completely solved for. Doesn't matter if the variable is y, doesn't matter if the variable is x. What it means to have a variable completely solved for is for it to be isolated on one side of the equal sign. So here, if you look, we have y completely solved for on this top one. So since on one of these linear equations, we have a variable isolated, substitution method would be a good method for solving this problem. If you want to check out the other methods, you can watch my other videos on those. So let's go ahead and get started. Here we have y is equal to 3x minus 1. It's completely isolated. And we have 2 variables, so we can't actually fully solve these equations just how they are. So we need to do something to it. Well, since y is equal to 3x minus 1 for this equation, this y actually has to equal the exact same thing. So what we're going to do is we're going to take this part of the equation, the 3x minus 1, and we're going to sub it in for that y in the second equation. So we get is 6x minus, and then we're going to put parentheses around what we plug in. Okay, it's a good habit to build, put parentheses around it. And we're going to plug in what was in the other equation, what y was equal to, which is 3x minus 1. We can go ahead and close those parentheses and set that equal to 0. So notice that the rest of the linear equation is the same. We just substituted out the y. And if we look at our new equation here, we only have the x variable. So now we can solve for this normally. So let's go ahead and distribute this negative into the parentheses. And our new equation after we distribute that negative will be 6x minus 3x plus 1 is equal to 0. I'm going to continue my work over here. We need to combine like terms, and the two terms we're going to combine are these x's. So let's go ahead and combine those. 6x minus 3x is 3x plus 1, which is equal to 0 still. And now we need to isolate our x variable. Our next step is to subtract 1 over, subtract 1. Then I get 3x is equal to negative 1. And then my last step is to divide both sides by 3. And I get x is equal to negative 1/3. Okay, now for the record, if you stop here and you're like, hey, this is my answer right here, I'm sorry, you would get the question wrong. You would get it wrong because this is only half the answer. As a reminder, when I talked about the beginning of the video, your answer should always be x comma y. So we need the y variable as well. So we found x. Now what we're going to do is we're going to take this x and we're going to plug it into either of the original two equations. Doesn't matter which one. I suggest you choose the one that looks easier, but we're going to plug it into either equation. I'm going to plug it into the top one and solve for it. So our top equation was y is equal to 3 times, put parentheses around it when we plug it in. So we're going to do negative 1/3 because that's what x was. Close our parentheses, minus 1. Okay, and now we solve normally for y. Distribute this in. We get y is equal to 3 times negative 1/3 is negative 1 minus 1. Negative 1 minus 1 is negative 2. And that is our answer for y right there. Now, whenever you're solving these on a test or just on any worksheet, I do suggest that you circle the x and the y value that you solved for, but you should also write it as a point, because after all, that's what you solved for. You solved for a point. So negative 1/3, comma, negative 2. Okay. Couple of things to emphasize before we move on to our next problem. If you notice, this was a problem where it has one solution. We found one point where they crossed, that being negative 1/3 and negative 2. So that worked out nicely. Here's the other thing. Students tend to freak out when they get a fraction as an answer. Fractions are perfectly okay. The lines can cross wherever, right? Like fractions are possible, whole numbers are possible, crazy infinite numbers are possible. All of that's fine. Just if you get a fraction, maybe double check your work, right? Teachers tend to want to be nice and we give you guys whole numbers, but fractions are acceptable. I cannot emphasize that enough. Okay, now let's move on to the second problem and let's clear off the board. Okay class, before we actually move on to problem 2, I totally forgot how to show you guys how to check your answers for problem 1, which is just total rookie move by me. So let's go over how to check your answers. As a reminder, for problem 1, this was our system of linear equations, and this was the answer we got, negative 1/3, comma, negative 2. It was one solution, there was our answer. There's 2 ways you can check your answer. One of those ways is you could open up a graphing calculator like Desmos, and you could graph the 2 lines. So if this was your graph, you could graph both lines, and where they cross is your answer, and you can click on that point and it will tell you the exact point. This is definitely in the wrong location, but that's all right. you click on it, it'll tell you the point, and that's a good way to check your answer. So graphing calculator, Desmos is a free online graphing calculator if you want to use that one. Okay, now for the other way, we can check it algebraically as well. Since these are our answers, and as a reminder, it's always x comma y, since these are our answers, we can take them and plug them into our original equations. And then we can solve to see if it makes them true. So let's look at this first equation and start plugging things in. So let's plug in our -2. So our y becomes -2, which is equal to 3 parentheses -1/3, close our parentheses, -1. And now we can solve. So we distribute that 3 in. -2 is equal to 3 times -1/3 is -1, minus 1 from the original equation. -2 is equal to -1 minus 1 is equal to -2. And that is in fact true. So that is a way that we are able to check, hey, this was an actual solution. And it is good practice to check it for both of them. Like if this is a test, I strongly suggest that you check it for both. So we got 6. We're going to plug in what we have for x, which is -1/3, close the parentheses, minus parenthesis -2 for our y, and that's all equal to 0. Okay, let's go ahead and solve this. We distribute the 6 in. 6 times -1/3 is -2. We can distribute this negative in as well. Negative times a -2 makes it a +2, and that's equal to 0. -2 plus 2, that does in fact equal 0. So 0 is equal to 0. We get that as our answer there, which is true, right? 0 is in fact equal to 0. So we just double checked our work by plugging our point into both our equations and seeing if it made them true, which in this case, it made them both true, so we know for sure that this is a solution. So with that being said, moving on to problem 2 for real this time. Okay, class, here's our second problem on how it might be presented to you. So problem 2, solve the following system of linear equations. So it's just asking us to solve it, which is still the same thing. We're going to check and see if these lines have any intersections. And if they do, we're going to solve for it. So looking at these two, here's what we're going to do. First step, we're going to check, is this a good substitution problem? X is by itself. That is a variable completely isolated. Since we have a variable completely isolated, substitution works great here. So we are going to use the substitution method. Once again, the same concept applies when we have x isolated. Since x is by itself, x is equal to 2y minus 1. Well, since this x is equal to 2y minus 1, that also means that this x right here also has to equal 2y minus 1. So we're going to sub out that x. And our new equation is going to be 4y is equal to 2 times 2y minus 1. As a reminder, we always, when we plug things in, put parentheses around it. And now if we check, we don't have any variable other than y. We only have one variable and we can solve for it normally. So let's go ahead and solve for it. Our first step is we should distribute this 2 in, and I get 4y is equal to 4y minus 2 plus 2, okay? Now I'm gonna rewrite it over here. I'm gonna continue my work. So we were at 4y is equal to 4y minus 2 plus 2, okay? Now let's continue to isolate the y's, and we're gonna do that first by combining like terms. So -2 plus 2 is 0. That gives me 4y is equal to 4y. And we could stop here, actually. We could stop here. And the reason why we could stop here is, if you look, both sides of our equation has the exact same thing. They're exactly the same. 4y is equal to 4y, which is true, right? 4y is in fact equal to 4y. So what this means, since both sides of the equation are the same, this one is infinite solutions. Infinite solutions. Or all solutions. Secretly, these two lines are the same. They're the exact same line. And like, you can't really tell that just by looking at it, right? Like, that's kind of tricky to be able to tell. We can make these pretty tricky. So don't just assume whenever you look at something like, oh, this is infinite solutions test. Just double check, okay? If you weren't satisfied with us stopping here, you could have continued. So I want y by itself. I could divide both sides by 4, divide both sides by 4. I get y would be equal to y. Once again, both sides are the same, so infinite solutions. If you're still not satisfied, we could subtract y from both sides, and we could get 0 is equal to 0, which that's completely true. 0 is in fact equal to 0. So our answer would be infinite solutions. And when you're answering it on a test, this is what you'd say. You'd say all or infinite solutions. That is your solution. So what that means is any number I plug in for x or y would make this equation true. With that being said, let's move on to our third problem. Okay, class, and now we've arrived to problem 3. If we look here, we have another system of linear equations that we're going to solve for. And looking at it, we don't have a variable completely isolated. Y has an x right next to it, same thing with this y. Neither of the x's are by themselves. So this would be an example of where one of the other methods might work better. But as a reminder, what I said at the beginning, substitution method actually always works. We can always use it. Since that is the case, let's go ahead and still use the substitution method on this. What we need to do is we need to isolate a variable. Doesn't matter which variable or from which equation, we just need to choose an equation and isolate a variable from it. So I think I'm going to take this top equation and isolate y, because y is really close to being isolated. The only thing we need to do is move that x over. So let me rewrite it down here. Y is not equal to, plus 1/2 x is equal to 6. And what we're going to do is we are going to subtract 1/2 x from both sides. And I get y is equal to negative 1/2 x plus 6. Y is completely by itself. It doesn't have anything with it. So now I can go ahead and use the substitution method. What we're going to do is, since y is equal to negative 1/2 x plus 6, we're going to take this and we're going to substitute it in for our y in the second system. So let's go ahead and do that. We're going to rewrite it over here and work over here. So I get negative 2, and then let's plug in what we have down here, times negative 1/2 x plus 6 minus x is equal to negative 8. Okay? Now we have it set up. We can go ahead and solve normally. Let's just double check that we only have one variable. We only have one variable, that being x both times, so let's go ahead and solve it. So let's distribute this negative 2 in. Bam, bam. Negative 2 times negative 1/2 gives me positive 1. So this is going to be x. Negative 2 times 6 is negative 3. So minus 3 minus x, and that is equal to negative 8. Okay, let's go ahead and combine like terms. We can combine our two x's. So x minus x gives us 0. So our x's actually just disappear. So that's kind of nice, right? Negative 3 is equal to negative 8, and we stop there. There is our answer. If you look, we don't have any variables left, right? No variables are left, and we have a statement that is just blatantly untrue. Negative 3 is not equal to negative 8. That is just false, right? So since we have a false statement as our answer is actually no solution. These two lines are parallel lines. They never actually cross. And if this was a test or something else like a worksheet, this is the answer you would write. You would write no solutions. Okay, so that was our third problem. We kind of showed how you can reorganize your equations to have an isolated variable. Substitution always works for solving these. You just might have to mess around with the original functions at the beginning. So with that being said, that is the lesson for today. Thank you guys so much for coming and watching the video. I suggest you check out the other methods. You should try and get really good at one method, but you should still know how to do the other ones, as it can cut time and make things a lot easier on you. So with that being said, thank you guys for coming to class today.